Hello everyone, welcome back. This is lesson 3 of our Python fundamentals series. Today we're going to be taking a further look at datasets, and we're going to be looking at dictionaries. So what is a dictionary? A dictionary stores data as key and value pairs. And here's an example. So we've got this variable named person, and person is equal to a name, which is Alice, and the age, which is 30. So in Python, a dictionary lets you store related information using keys and values, just like how you look up a word, a key, and find its meaning, a value. So name would be the key, age would be the key, Alice would be the value, 30 would be the value. So it stores different data or data items as key and value pairs, separated by colons. Okay, so essentially the basis of a dictionary, it uses curly braces. So when you see the curly braces and items separated within that list, so to speak, by the colons, just know that you're looking at a dictionary. Okay, and one last piece of information is that the keys must be unique. Each key can only appear once in a dictionary, but the values can repeat. Access and values. First, you need to have a dictionary variable to work with. Place the key inside square brackets after the dictionary name. The expression returns the value associated with that key. Use the key to get the value. For example, print person brackets name, and it will return Alice. So if we see in the previous example how we write the dictionary key and value pairs, we have name and we've given it the value of Alice, but in order to iterate over that dictionary pair and to call that name, we are using here of course a print function indicated by print brackets, and then we've passed in the variable of person, and we want to find the value of the key name, which will return Alice. And so this is how we iterate over it, just using the brackets, similar to how we was working with when we was working with lists. Adding and changing items. So first, if we want to add or update our items within a dictionary, what we can do is decide, of course, which key to add or modify. We access the key position in the dictionary using square brackets, and we use equals to set a new value for that key. So here's an example. So we want to add a value. So person, we want to add the key of job. So you put job, and we want to add a value to that of engineer, and we do it simply just like that. And let's say we want to update the age variable, seeing that we can only have one the key value pair of age, so we can only have one key being the same name. So if we wanted to add the age variable, it's just going to update, seeing as we already had an age key in that person variable, if that makes sense. So if we go back, the age for Alice is already set to 30. So now when we're looking to update the value, if we call person age, the computer already has it stored in its memory as 30. So when we do person brackets age and put 31, that's just going to simply update. Whereas we do person job, since the key value pair of job does not yet exist, it's going to add job to this dictionary. And similarly, we can remove items by using the prefix del, call the variable person again, and then put in the brackets what key value pair we want to delete. So in this case, job will completely remove the items from the list. And similarly, we can use what's known as pop. So pop is very similar to delete, but it will remove the key value pair, but it will return the value. So it's useful when you need to use the value whilst you're also removing it. So to delete items, you use del or pop. Del removes the pair completely. Pop does the same thing, but also gives you the value back. So you can think of it like cutting a coupon out of a magazine to use rather than throwing it away. So we do that like so. Age equals person, the variable, dot pop age. Okay, so in this case we want to use the value, so we're going to store the value that we're essentially popping or deleting from our dictionary. So we're deleting a value from our dictionary, but we're storing it in this new variable called age, which is separate from our dictionary list. So age will no longer appear in our dictionary. However, we're going to be storing age. We're going to be storing that value of age in this new variable simply called age. Okay. Alright. Checking for keys. Question. We need to check if a key already exists, as you cannot have duplicates. Code. Use the in keyword with dictionary. Result will get true or false boolean. Action. Proceed based on the result. So what do we mean? So we use the in programming term in order to check if a key already exists. So if we say if name essentially appears in the person variable, print name found. And because in this scenario where we're using the person object, we do have the name and the age variables, so this will be resulting as true, and so it will print name found. So this is what we call a boolean, where it's deciding is this statement true or false. So does name appear in our dictionary? Yes or no? True or not true? True or false? And in our case, because it is true, it's going to be printing out name found. Looping through a dictionary. So we start the loop, use for with keys, value, variables, call.items, gets all the key value pairs, process each pair, work with both key and value. You can loop for a dictionary using the .items method to get both the key and the value. So similar to how we was working with in lists, for key value in person.items, print key value. So this is great for reading all the data in a clear and structured way. We're going to take a further look at this when we do our practical. So of course we have different methods that we can use in order to access dictionaries. So we have, for example, this is a more unique method to dictionaries, .keys, which returns a list of all the keys in the dictionary. We have .values, returns a list of all the values in the dictionary. And we have .items, which we have seen previously, returns a list of all key value pairs as tuples when working with dictionaries. And of course, we can also have nested dictionaries, a dictionary containing other dictionaries within it. Complex data structures is used to organize related information hierarchically and to store multiple records within detailed information. You can store dictionaries inside dictionaries just like so. So we have this variable called users, and we have two different users here, Alice and Bob, and we've got different information both about them, such as their age and their job. Okay, so what's the difference between a dictionary as opposed to compared to a list? You can see dictionaries are accessed by key and value pairs. Lists are accessed by index. A dictionary is accessed by key, List is accessed by index. The order, well, they're both preserved, so I wouldn't worry too much about that. And the speed, dictionary is very fast for lookup. A list is slower in terms of looking up. So unlike lists, dictionaries use keys instead of indexes. They're faster when you need to find something by name, by looking up a student by ID instead of guessing their position in a list. So of course, here's some real world examples of when you'd use a dictionary. A dictionary is perfect for storing student grades by name, simple code to store and retrieve student scores, easy lookup of any student's grade when you need it. And so here's a real world example, using a dictionary to store students and their grades. Example, we have grades equal Alice 88, Bob 75, Clara 92. So if you want to print grades of Clara, we would get it straight away. And so you can see it's much faster than indexing. It's a clean and direct way to manage and retrieve information. So just a quick recap. Dictionaries store key value pairs. This is the fundamental structure of Python dictionaries. It's indicated by the use of the curly braces with a key and value format. It's accessed with keys and not indexes for how we retrieve the values from our dictionaries. You can update, delete and loop over them easily using the common methods which we had spoken about previously, and it's great for structured data. Ideal use case for dictionary and data structures. Okay, and now we're going to go over to a few practical examples. Okay, so here we are, we're back in our Google Colabs workspace where we can write some code. As you can see, we have the output from our previous lesson. So we're just going to go ahead and delete this and add a new code cell to begin writing some new code. Right, so I have this piece of pre-written code here, just reminding you of the different data types which we can store. So for example, I've got a name variable which we have set to Alice, which is a string, i.e. text. We also have an age variable which is set to 25, which is an integer, in other words a whole number. Alice is of height 5.6, so this is a float number or a decimal place. And we have is student, so we have set this to true, and this is a boolean value which can either be true or false. So when we call the print function, remember this is used to print something on the screen, we want to print the type, so we're using the type function also within the print function. We want to print the type of name. We want to know what data type is name. As we've already established, it is of the type string, and so we expect the output to show class string. So if we run this code here, perfect, our code is working as it should. Alright, so I'm just going to go ahead and delete this also, add a new code block, and let's take a look at an example of a list. So I've created two lists here, the first being fruits with 3 items in this list, and we've got numbers ranging from 1 to 5. So remember that when we want to reference, or otherwise known as access or index a list, that the first item in the list starts at position 0 as opposed to position 1. So apple will be at position or index 0, banana index of 1, and orange has an index of 2. Okay? In the same way, numbers, even though it being number 1, it is at the position of 0. So when we want to index number 1, we would say print numbers, square brackets, 0. Okay? Just as you can see in these examples here. It's also important to note that there's different ways to access the items within a list. So if you want to call the last item in the list, i.e. orange for fruits, we can also do that by indexing the index of -1, position of -1 will bring forth the last item in the list. Okay, so we can also call or index the position of orange by saying number 2. Okay, don't believe me? Let's run this piece of code and see what we get. As you can see, orange has been displayed using the print function twice. Okay, perfect. Lastly, I provided an example of when we want to use a method onto our list. So we have the append method, whereby we are going to add something to this list. In this case, we're going to add some grapes, because who doesn't like some grapes, right? Okay, so as you can see here, when we run this piece of code, we've now added to our list grapes. So let's say we want to also add strawberries to the list. We're going to use the same example. We'll just copy and paste that here. And we'll just simply change this to strawberry. And if we run this piece of code, let's see what happens. Strawberries has not been added to the list. Why is that? It's because in programming in Python, everything is read from the top down. So the computer is running this code from the top down, right? And so this print statement, because it comes before this last piece of code written here, it doesn't know to display the new value of our list. So to solve this, all we need to do is move this print function to the last line, so that now it will include strawberries in our list. We run this piece of code, perfect. We can see that strawberries has now been added to our list. So let's add in a new code cell, and let's take a look at an example of some tuples. So remember, tuples are essentially the same as lists. The only difference being that instead of using the square brackets, they are formatted using curly brackets like so. So you've got two lists here, coordinates 10, 20, and a colors variable with 3 different colors, red, green, blue. Accessing or indexing them works in exactly the same way. So if you wanted to know coordinates 0, this is going to display 10 being the first item in our list. However, the one difference with tuples as opposed to lists is that they are immutable, meaning they cannot be changed or appended in the same way. So let's do a simple example where we're going to change the coordinates from 0. We're going to change coordinate 0 from 10 to 15. Okay, and then we're going to once again print the coordinate of 0. Let's see what we get. Okay, we've got a syntax error there. Let's do that again. It's because we missed out the brackets at the end. So if we run that command again, type error. You cannot change the type. Okay, so you're getting a type error because tuples, unlike lists, are immutable, and so once we try to change the coordinates from 10 to 15, we are now getting a type error. Okay, because it doesn't support, tuples do not support being changed, they are immutable. Okay, so that concludes lesson 2, where we're looking at data types, in particular tuples and lists. In the next lesson, we're going to look at some more data types, and in the next lesson we're going to look at some tuples and lists. In the next lesson, we're going to look at some more data types. See you in the next one. Bye bye.